This video demonstrates the Syncious platform using Ansys Fluent. The demonstration includes pre-processing, solving, and post-processing of Ansys Fluent on Syncious platform. I'm logging on to the uh, Syncious HPC platform. Once I get logged in, I can see a dashboard with the HPC cluster with name test class 78 and it has a head node of 4 core and compute nodes of 16 core each. So this is a total of 128 core HPC cluster. Right now, only head node is active, which is used for management of HPC, and one of the compute node is in active state. Other nodes are in inactive state. Mm, Workstation 1 is the Windows machine with graphic processor, which can be used for the pre-processing and post-processing operation. Now, there can be multiple users in the organization. Here you can see there are 5 users. So each one will have their own workstations, and we built a VDI, virtual desktop infrastructure capability on the Syncious platform so that each user can access their own workstation. So right now I'm connecting to the workstation 1, which I can see here. So when I click connect button, it should download the remote desktop file. Yeah, so the remote desktop protocol file is downloaded and I can connect to this file. So, so this work we are connecting to the workstation 1. You can see the IP address on to top of that machine. So on the workstations, you can see two drives mapped. One is a sync store and one is work store. Sync store is the drive that is storage that is provided by Syncious, which can be used to upload and download data, whereas work store is a runtime storage, which is a high end SSD storage where you can actually run the simulation and keep your working data on this machine. So let's open the Fluent in the meshing mode right now, and we can directly open the files for the work store. This work store is shared between all the compute nodes and all the nodes on this HPC cluster so that they can share the data. I'm importing the CAD geometry file from the work store itself. Let's give units as millimeters, and once this geometry gets imported, we can start the meshing on this CAD file. So I'm entering the scaling. So let's import the file now. So import is going to take some time. So while that import takes time, I will show you another options to do a pre-processing. So workstation 1 can be used to do a pre-processing, which is a Windows node with a GPU capability. But the compute nodes can also be used to do a pre-processing, though those are the Linux-based nodes. So if you go to the view workspace here, it will connect to the Linux based machine to the HPC cluster, and you can do a small tweaking or changes in the pre-processing on that Linux machine itself. So here you can see that there is a Linux desktop shown onto the browser itself, and you can do a small changes in the pre-processing if you need to do before actually executing the simulation onto the Syncious cloud. So let's go back to the Windows machine here. The workstation. We are still waiting for the import to complete. It I assume it will complete in some time. Okay, yeah, so it's reading data and it's almost done. Okay, so you can see after import, there are meshing objects, and I am just drawing that object. So this is an exhaust with four inlets and one outlet. Let's start the pre-processing on this model. I can select the points to cap these inlets and outlets. So let's patch the outlet first. Mm, I'll just label it as outlet. Mm, So outlet is patched. Similarly, we'll patch the uh, inlet. All four inlets can be capped at a time. Yeah. So we have capped the inlets and outlets. Now uh, let's extract the fluid volume from this exhaust because we are mostly interested in the fluid uh, in this problem. So let clip the planes to extract the fluid first. So I'm clipping the planes here, and uh, using we need to add the material points for fluid here. So let's name it as a fluid, and we'll select two nodes to assign the fluid volume. I'm assigning the first node, and the second node at the bottom can be assigned. And with that, uh, can compute and prove whether it's correctly placed. Yeah, so it looks like a correctly placed for the fluid volume. Um, so let's create this material point here. And yes, so the fluid material point is created. We should also compute the fluid volume here. So in volumetric region, I am just going to compute this fluid region, which is done. So now let's go to the cell zones and draw. In fact, let's do a automatic mesh. We are not interested in solid cells. We'll use prisms, scoped prisms, and poly meshing, and we'll select merge cell zones also. After apply, do let's start meshing. Yeah, so it's generating prisms now. Looks like it's done now. It's improving the mesh, so merging some of the edges. Yeah, looks like we are done with the meshing. Let's close this thing and let's see how that looks after meshing. You can see this is a volume, fluid volume, and you should select face edges to see exactly how the it looks. It's looks like a well defined mesh. Yeah. So now once mesh is defined, let's go to the solving mode. We will not use Workstation to do a solving. The reason being we want to show you the Syncious platform and the HPC cluster to execute solution on this problem. So only thing what we will do on this workstation is we can do the initialization part of the solving. Even that can be done at the HPC cluster, but uh, let's do it here. So this is a problem that we imported onto the solver, Syncious solver. Sorry, Fluent solver. Okay. Now, I think we should just select some of the parameter, like we need a steady state. The viscous model, let's select it as a k epsilon, and we should add the boundary condition. So for inlet, we'll add the velocity of 10 meter per second and turbulence intensity of 10. Okay. So this is applied to one inlet. We can copy the same boundary conditions to all other inlets. Okay. So now we have to add boundary conditions to outlet as well. So again, backflow turbulent intensity of 10, same which is used for inlet can be added here. So 10. Okay. So we have set the boundary conditions and we are ready to start solving. So let's go in the solving and initialize this problem. Once the initialization is done, we should save the case and data file onto the work store, that is W directory. So let's save it as demo.ks.gz. So because we stored it onto the work store, the same work storage can be used or same storage can be used by the HPC cluster to solve this problem. So it's done. Now you can see this demo cache and dat files are stored in onto the work store. Now we can go, you can actually calculate from here onto the workstation if the problem is small like this problem, then it can be done from here, but I will show you how you can use the Syncious HPC cluster to solve this problem. So, this we are at again back to the dashboard. We will solve this problem. It's a very small problem. We'll just use one node which is currently already active state to submit the job, Fluent job. So we'll create a new job, um, job name, uh, like demo, and we can solve this problem on any number of cores like 128 if all nodes are active, but right now we'll just run it on 2 cores because it's a very small problem to solve. Okay, on next I will select the case and data file which was already saved while after doing a pre-processing. So it was saved in the work store. So I selected work store. Inside work store, you have this demo folder. So I'm selecting cache file here, and similarly I will select the dat file as well. Okay, so both files are selected. We should enter some output file as well. And yes, you can add some more files like user defined function if it is there. So once this is done, I will add some Fluent settings like 500 iterations that we need to run it on. I will not copy data back to our storage, sync storage. Uh, so the data will still be kept at the work storage, which again we will access for the post processing later on. So this is the recently submitted job. Just now we submitted job. It's in queue right now. Let's wait until it moves ahead and it should reach to the job execute state. So data copy is generally used if you copy data in the sync store or upload data into the sync store. Sync store is like a Google Drive or Dropbox option from Syncious, and the data will get copied from there to the working directory. Now job data copy stage has been passed because already the data was in working directory. Now job submit is in progress. It will at the job submit it will create some of the configuration data to make sure that it gets properly processed onto the HPC cluster. So it's still in that state. Let's go back and see onto the work store whether what is happening. So so in Dhruvid, it created a new directory called demo fluent, and these input files are there, and few files, more extra files got created based on your input and the configuration. So yeah, so job execution started, it is in progress. Let's see the output of the Fluent. Yeah, you can see this is the output is generated. So the number of iterations, you can see here. Yeah, so you can monitor the output from the same window itself. I think let's wait until the job gets completed and then we will demonstrate the post processing part of this job. Okay, so